This video is part of Electrify Everything, a very short course. In this episode, we ask, why are heat pumps so cool? We'll use colors to represent temperatures. This red will be for when it's hot outside, say 90 degrees Fahrenheit in summer. This yellow will be a comfy temperature, close to what we might call room temperature, like 70 degrees Fahrenheit in spring. And blue will be for cold, like when it's 0 degrees Fahrenheit in winter. A house with no heat will be cold on a cold day. To heat it up, you need something hot like a fire. And we'll use a red arrow to represent flowing heat. The heat produced by the fire warms up the house. And as the house warms up, heat starts to leak out. And that's because heat naturally flows from warmer to cooler places. Adding insulation, represented here by thicker lines, reduces the leaking heat, which is represented by the smaller arrow. And that's a basic explanation of home heating by fire, which humans have been doing for thousands of years. Instead of a fireplace, many homes use a boiler or furnace for home heating. Most boilers burn fuel oil, fossil gas, or propane to heat water. And I made a little model of a boiler with a glass of water being heated by a candle, which represents the fuel. And a pump moves the hot water to a radiator, which heats the room. And most boilers are over 80% efficient, meaning that at least 80% of the energy from the fuel source is used to make the water hot. Another form of heating is electric resistance heating. Here, electricity passes through resistance wire, such as nichrome, and it heats it up. It even glows, as you can see in the video. And you're probably familiar with the glow of resistance heating, since it's used in space heaters, old-school electric burners, and toasters. Resistance heaters can be 100% efficient at turning electricity into heat, which sounds great, but we can do even better than 100% using heat pumps. So the type of heat pump shown here has an indoor unit connected to an outdoor unit. And instead of producing heat from burning, like in the fireplace, boiler, or resistance heater, it's just pumping heat from a lower to higher temperature. Surprisingly enough, even very cold air has heat available for pumping. The heat pump uses a fluid called a refrigerant to absorb and move heat. These images are taken with a thermal camera where blue is cold and red is hot, and the heat pump makes the refrigerant colder than it is outside so that it absorbs heat. So even if it's 0 degrees Fahrenheit outside, in cold climate heat pumps, the refrigerant can be made even colder than that so that the heat will flow into it. Then the heat pump moves the refrigerant inside and it makes it hotter than it is inside to release the heat. The refrigerant is actually similar to this red fluid absorbing heat from my hand. In fact, this is a rough model of how a heat pump works. The heat naturally flows into the refrigerant and then it's moved around. But obviously it's a little more complicated than that, so let's check out this heat pump exhibit at the Exploratorium in San Francisco. Here, the refrigerant is sealed in these pipes, and I'm powering a compressor to increase the pressure and heat the refrigerant. Then I open a valve and release the pressure, which expands and cools the refrigerant. And if we look at it through the thermal camera, the left side gets cold and the right side gets hot. So after the valve, the refrigerant expands, gets cold, and absorbs heat. And then it flows to the other side where the refrigerant is compressed, gets hot, and dumps heat. And this is how heat flows into the cold side and out from the hot side. And actually, this is how an air conditioner works. Electricity provides the energy to run the compressor, which I've indicated with a yellow arrow, and it's not hand cranked, as you might have guessed. And a heat pump is really just a reversible air conditioner that can both heat and cool. So here, it's cooling down the inside of the house by pumping it to the outside on a hot day, and that's opposite the direction that heat naturally flows. And here, it's heating up the inside of the house by pumping heat in from the outside on a cold day. Again, opposite the direction it naturally flows. Best of all, heat pumps can be 400% efficient, which is pretty cool. But what exactly does that mean? Well, it means that while boilers and furnaces that produce heat by burning fossil fuels can be around 80% efficient or, better, up to 100%, and electric resistance heaters that produce heat from electricity can be 100% efficient, heat pumps that use the same amount of electricity are really just pumping existing heat and can be 400% efficient, giving you much more heat than the energy you put in. And this is another reason we say that electrification is the efficiency, because if we switch from fossil fuels to electricity, particularly in heat pumps, we can have much more efficient appliances. So, in summary, heat flows from warmer to cooler by itself. It can be produced by burning fuels and by electric resistance. And heat that already exists can be pumped very efficiently by an electric heat pump for both heating and cooling, even on a very hot or cold day. All right, if you've got any questions, email us, schools@rewiringamerica.org.